A USB hub is a device that expands a single universal serial bus port into several so that there are more ports available to connect devices to a host system. USB hubs are often built into equipment such as computers, keyboards, monitors, or printers. When such a device has many USB ports, they all usually stem from one or two internal USB hubs rather than each port having independent USB circuitry. Physically separate USB hubs come in a wide variety of form factors, from external boxes connectable with a long cable, to small designs that can be directly plugged into a USB port. In the middle case, there are short cable hubs which typically use an integral 6-inch cable to slightly distance a small hub away from physical port congestion and of course increase the number of available ports. Laptop computers may be equipped with many USB ports, but an external USB hub can consolidate several everyday devices into a single hub to enable one-step attachment and removal of all the devices. Physical layout. A USB network is built from USB hubs connected downstream to USB ports, which themselves may stem from USB hubs. USB hubs can extend a USB network to a maximum of 127 ports. The USB specification requires that bus-powered hubs may not be connected in series to other bus-powered hubs. USB ports are often closely spaced. Consequently, plugging a device into one port may physically block an adjacent port, particularly when the plug is not part of a cable but is integral to a device such as a USB flash drive. A horizontal array of horizontal sockets may be easy to fabricate, but may cause only 2 out of 4 ports to be usable. Port arrays in which the port orientation is perpendicular to the array orientation generally have fewer blockage problems. External octopus, or squid hubs, or star hubs avoid this problem completely. Length limitations USB cables are limited to 3M for low-speed USB 1.1 devices. A hub can be used as an active USB repeater to extend cable length for up to 5 meters lengths at a time. Active cables perform the same function, but since they are strictly bus-powered, externally powered USB hubs would likely be required for some of the segments. Power. A bus-powered hub is a hub that draws all its power from the host computer's USB interface. It does not need a separate power connection. However, many devices require more power than this method can provide and will not work in this type of hub. It may be desirable to use a bus-powered hub with self-powered external hard disk units, as they may not go into sleep mode immediately upon computer shutdown or sleep mode when using a self-powered hub since they will continue to see a power source on the USB ports when using a self-powered hub. A USB's electric current is allocated in units of 100 mA up to a maximum total of 500 mA per port. Therefore a compliant bus-powered hub can have no more than 4 downstream ports and cannot offer more than 4 100 mA units of current in total to downstream devices. If a device requires more units of current than the port it is plugged into can supply, the operating system usually reports this to the user. In contrast, a self-powered hub is one that takes its power from an external power supply unit and can therefore provide full power to every port. Many hubs can operate as either bus-powered or self-powered hubs. However, there are many non-compliant hubs on the market which announce themselves to the host as self-powered despite really being bus-powered. Equally, there are plenty of non-compliant devices that use more than 100 mA without announcing this fact. These hubs and devices do allow more flexibility in the use of power, but they are likely to make power problems harder to diagnose. Some self-powered hubs do not supply enough power to drive a 500 mA load on every port. For example, many 7-port hubs have a 1A power supply, when in fact 7 ports could draw a maximum of 7x 0.5 equals 3.5A, plus power for the hub itself. Designers assume the user will most likely connect many low-power devices and only 1 or 2 requiring a full 500 mA. On the other hand, the packaging for some self-powered hubs states explicitly how many of the ports can drive a 500 mA full load at once. For example, the packaging on a 7-port hub might claim to support a maximum of 4 full-load devices. Dynamic-powered hubs are hubs which can work as bus-powered as well as self-powered hubs. They can automatically switch between modes depending on whether a separate power supply is available or not. While switching from bus-powered to self-powered operation does not necessarily require immediate renegotiations with a host, switching from self-powered to bus-powered operation may cause USB connections to be reset if connected devices previously requested more power than still available in bus-powered mode. Speed. To allow high-speed devices to operate in their fastest mode, all hubs between the devices and the computer must be high-speed. High-speed devices should fall back to full speed when plugged into a full-speed hub. While high-speed hubs can communicate at all device speeds, low and full-speed traffic is combined and segregated from high-speed traffic through a transaction translator. Each transaction translator segregates lower-speed traffic into its own pool, essentially creating a virtual full-speed bus. Some designs use a single transaction translator, while other designs have multiple translators. Having multiple translators is a significant benefit when one connects multiple high-bandwidth full-speed devices. It is an important consideration that in common language USB 2.0 is used as synonymous with high speed. However, because the USB 2.0 specification, which introduced high speed, incorporates the USB 1.1 specification such that a USB 2.0 device is not required to operate at high speed, any compliant full-speed or low-speed device may still be labeled as a USB 2.0 device. Thus, not all USB 2.0 hubs operate at high speed. Equal speed of USB 3.0 hubs with USB 2.0 devices equals. With USB 3.0 hubs there is a significant caveat to be aware of when attaching USB 2.0 devices. All USB 3.0 hub implementations treat the USB 2 and USB 3 buses separately. USB 2.0 device traffic is not aggregated onto the 5 Gbps USB 3.0 host connection. Hence performance in this case is the same as if using a USB 2.0 hub. The USB 2.0 devices all compete for the same 480 Mbps USB 2.0 host bandwidth and the super speed capability is not utilized. Protocol: each hub has exactly one upstream port and a number of downstream ports. The upstream port connects the hub to the host. Other hubs or devices can be attached to the downstream ports. During normal transmission, hubs are essentially transparent. Data received from its upstream port is broadcast to all devices attached to its downstream ports. Data received from a downstream port is generally forwarded to the upstream port only. This way, what is sent by the host is received by all hubs and devices, and what is sent by a device is received by the host but not by the other devices. Downstream routing has been changed in USB 3.0 with the addition of point-to-point routing. A route string sent in the packet header allows a USB 3.0 host to only send a downstream packet to a single destination port, decreasing congestion and power consumption. Hubs are not transparent when dealing with changes in the status of downstream ports, such as insertion or removal of devices. In particular, if a downstream port of a hub changes status, this change is dealt with in an interaction between the host and this hub. The hubs between them act as transparent in this case. To this aim, each hub has a single interrupt endpoint in use to signal changes in the status of the downstream ports. When someone plugs in a device, the hub detects voltage on either D+ or D and signals the insertion to the host via this interrupt endpoint. When the host polls this interrupt endpoint, it learns that the new device is present. It then instructs the hub to reset the port where the new device was plugged in. This reset makes the new device assume address 0, and the host can then interact with it directly. This interaction will result in the host assigning a new address to the device. Transaction translator: any USB 2.0 hub that supports a higher standard than USB 1.1 will translate between the lower standard and the higher standard using what is called a transaction translator. For example, if a USB 1.1 device is connected to a port on a USB 2.0 hub, then the TT would automatically recognize and translate the USB 1.1 signals to USB 2.0 on the upper link. However, the default design is that all lower standard devices share the same transaction translator and thus create a bottleneck, a configuration known as the single transaction translator. Consequently, multi-transaction translators were created, which provide more transaction translators such that bottlenecks are avoided. Note that USB 3.0 hubs unfortunately do not currently perform transaction translation to superspeed for USB 2.0 devices. Electronic design: most USB hubs use one or more integrated controller ICs, of which several designs are available from various manufacturers. Most support a 4-port hub system, but hubs using 16-port hub controllers are also available in the industry. USB hubs could be cascaded up to 7 levels deep, however maximum number of user devices is reduced by number of hubs. With 50 hubs attached, the maximum number is 127 of 50 equals 77. Additional features on some hub controllers include control of port LEDs and PS/2 to USB conversion for mice and keyboards. Inverse or sharing hubs, also available, are so-called sharing hubs, which effectively are the reverse of a USB hub, allowing several PCs to access a single peripheral. They can either be manual, effectively a simple switch box, or automatic, incorporating a mechanism that recognizes which PC wishes to use the peripheral and switches accordingly. They cannot grant both PCs access at once. Some models, however, have the ability to control multiple peripherals separately. Only the simpler switches tend to be automatic, and this feature generally places them at a higher price point too. Modern KVM switches can also often share USB devices between several computers. See also, USB on the go. References: USB technology, multi-TT hub goes head-to-head with single TT. Tom's Hardware UK and Ireland. Retrieved August 24, 2006. Euro unregistered trademark S. The difference between USB 2.0 and 3.0 hubs. USB 2.0 specification, USB in a nutshell, single TT or multi-TT, USB technology, multi-TT hub goes head-to-head with single TT. tomshardware.com. September 9, 2003. Retrieved May 1, 2013. AP Gods. DA Gods. Advanced Microprocessors. Technical Publications. Pages 16. ISBN 978-81-8431-560-8. Retrieved January 3, 2013.